Okay, good morning class. So today we're looking at factorization. The questions or the PDF can be found in the description box below. At this point we're doing factorization. It is dealing with book A, sorry, book B, worksheet 1. We'll also do worksheet 2 in this video as well. Alright, so let's look at the first one. So here we're looking at, the question says factorize. Write infactorable if the polynomial cannot factorize into perfect squares, okay? 3 of the polynomials cannot factorize. So here already they're telling from the offset how many of them cannot factorize. Right, so let's look at the first one. How do you identify for a perfect square trinomial? There are 3 terms. That's number 1. Number 2, the first term and the last term are squares. And this has to be positive. If that is negative, then automatically it's not a square. Because I have negative times a negative is a positive. So this fit the criteria so far. So it's going to be, what's the square root of 4x squared? What's the square root of y squared? And there's a plus, so there goes plus. So we check for this middle term. What is 2x times y times 2? 4xy. And yes it is. Okay. Let's go with the next one. We got x squared y squared minus 12xy plus 36. Are there 3 terms? Yes. Is the first term and the last term perfect squares? Yes. So let's go with. So what is the square root of x squared y squared? xy. What's the square root of 36? 6. Then we take the sign in the middle term. Let's check if the middle term works. So it's xy times negative 6 times 2, which is negative 12x. Okay, you guys understand? You all understand? Okay. Number 5.
Your attention please. Miss Finter's grade 11, can you please report to our classroom now for your Afrikaans lesson? Miss Finter's
9x squared minus 6x plus 1. Is it 3 terms? Yes. Is the first and the last term perfect squares? Yes. So let's go. What's the square root of 9x squared? 3x. Minus? We test if it's conformant with the middle term. So 3x times negative 1 is negative 3x times 2 is negative 6x. Okay, you guys understand? Let's go to the next question. Are there 3 terms in that expression? Yes. Is the first and last term perfect squares? Yes. So what's the square root of 16a squared? 4a. Square root of 1? The sign of the middle term is positive. So let's test if it works. So 4a times 1 times 2 is 8a. So yes, it works. Let's go with the next question. Number 9. X squared plus 14x minus 49. Are there 3 terms?
Yes.
Are it the first and last term perfect squares? No. So it's infactorable. Is that correct? Infactorable, it cannot be factorized. Okay. Number 11. So you got 4x squared minus 10x plus 25. Are there 3 terms? Yes. Are the first and last term perfect squares? So the square root of 4x squared is your x, square root of 25 is 5. And you take the sign of the middle term. So we test. So 2x multiplied by negative 5 multiplied by 2. 2x times negative 5 is negative 10x times 2 is negative 20x. Is that the case? No. So what does that mean? So that's not the case. So this is infactorable. Okay, that's the second one now, no? Number 2. You see now why it's important to test. You see that, people? That's the importance of testing. Let's look at the next one, number 13. Why is it? Yes, it's 11, 13. Next. Because we're only doing the odd numbers. Yes? What's wrong? Yes, but I'm only marking the odd numbers in the video. Alright. So let's do the next one. Are there 3 terms?
Yes.
Are the first and last perfect squares? So it's going to give you 2x. 2x plus the square root of 1 over 16. 1 over 5 square. Let's test if it works. So it's 2x times a quarter times 2. 2 times 2 is 4 and 4 times a quarter is 1. So the answer is x. So yes, that one works. Okay. Number 15. You got x squared plus 2 over 3x minus 1 over 9. Are there 3 terms?
Yes.
Are the first and last term perfect squares? No, there's a negative. So it is. Okay. Alright. You guys understand? And those are, and that we picked up all 3 in this case. Not so. People, let's look at number worksheet 2. Book B, worksheet 2. So here we are told to factorize. We got ax squared minus 2axy plus ay squared. There are 3 terms, correct? Is the first and last term perfect squares? No, the a is not a perfect square. But what do I also notice? A is common. A is throughout. So what do? I take a out as a common factor. What am I left with? X squared minus 2xy plus y squared. What do I notice inside this bracket now? Is 3 terms? Is a perfect square trinomial. Because the first term is a perfect square and the last term, so you got a into square root of x squared, x and square root of y squared is 1. Here's minus, here goes minus squared. And we test if it works. What is x times minus y? Negative xy. Times 2? Negative 2xy. Alright, you guys understand? Any confusion at this point? None. Number 3. There are 3 terms. Is the first term and last term perfect squares? Huh?
My
No.
apologies for the interruption. Legal Martini, can you please report to the office?
So what do we notice here?
Martini in grade 9A, can you please report to the office?
What do you notice here? 5 can go into 40 and to 80. Which means to say 5 is a common factor. So you must take out, remember that common factor overrides all type of factorization. So if you see a common factor, you take that out first. Okay? So you take out 5 as a common factor. What are we left with? X squared minus 8xy plus 16y squared. And we can test if it's right. 5 times x squared is 5x squared, 5 times negative 8xy is negative 40xy, 5 times 16y squared is 80y squared. Can you see that? So again, it's 3 terms inside the bracket. Right. Is the first and last term perfect squares? Yes. So I'm going to do difference of 2 squares. What's the square root of x squared? X. Square root of 16y squared? 4. The middle term is minus. And of course we have to test. So we got 8x times negative 4y times 2. It's going to give you negative 8 xy. Okay. Any confusion there? So the next one. Are you finding this factorization? Easy, no? It's going to be worth a lot of marks. Okay. So, this is going to go into algebraic fractions as well, which makes it worthwhile knowing how to do all type of factorization. Okay. People, and then number 5 got 12a x squared y squared plus 60a xy plus 75a. Is there a common factor? What is common throughout? 12. How many times 12 going to 75? Not 12. It's 3. It's A, so 3a. That's so? So 12a x squared y divided by 3a. It's going to give you 4 x squared y squared. Plus 3a multiplied by what is 60a xy? 20 xy plus 3a times 25. There's 3 terms inside the bracket. Not so. Is the first and last term perfect squares? Yes. So let's go with the perfect square trinomial. What's the square root of 4x squared y squared? 2xy plus what is 2xy times 5? 10xy times 2? 20xy. You guys see that? Number 7 is the last one. What do you notice here? Is that in the standard form of a trinomial? The standard form is always going to be x squared, something x, and a constant. Not so? So I must get that in that form first. Okay? So I'm going to put that in front. So it's going to become minus 4x squared plus 4xy minus y squared. Okay, if there's a y here, then there will be something y squared, y and no y. That's a standard form. And then you want to make a note there. Is standard form of trinomial. Standard form of trinomial. Okay. Well, what does this dots mean? There's no many numbers there. No? People now in number 7 never answered the question. No. So what is the rule if the first term is negative? If the first term is negative. Did I make a note here? First term is negative, then you factorize. The negative side. We take out the negative as a common factor. Okay. So factorize the negative. We take out the negative as a common factor. So if I take the negative out as a common factor, what are we left with? 4x squared minus 4x plus y squared. Okay. There are 3 terms. Is the first term a perfect square? Is the last term a perfect square? So I can apply difference of 2 squares. What's the square root of 4x squared? Square root of y squared? And with a minus. This. Okay, I already forgot to put a y there. Can you see that? So what is 2x times minus y times 2? Negative 4xy. Which is correct. Do I have to show this calculation here? Okay. So that basically brings us to the end of worksheet 2 of book B. We're going to go into worksheet 3 and 4 now because you guys have done it already. Okay.